Okay, number 2, we're given 3 of the trig functions already, and then we want to find the other 3. Okay, so this one is straightforward. They give us the main functions. The main ones are sine, and this time they're using the Greek letter alpha. So it's like a X with a tail on it. That's kind of how I draw them. Alpha, sine of alpha is equal to the square root of 15 over 8. And then cosine of alpha is equal to 7 over 8. And then cotangent of alpha is equal to the square root of 15 over 7. So these other guys are just the reciprocal of them. So CSC. Okay, those reciprocals. What did I write cotangent in here? I'm so sorry. It should be tangent. Tan. T-A-N. The reciprocals kind of have the opposite letter. So S is matched with the C, sine and cosecant. All you have to do is flip it. So this would be 8 over the square root of 15. Now remember, we don't like square root on the bottom, so the simple way to think about the rationalizing of the denominator, you're multiplying square root of 15 on top and bottom, but what happens as an end result, the top term gets multiplied by that square root term, and then the bottom term just loses its square root. That is the long and short of what happens when you rationalize the denominator. So this is fine, no square root on the bottom. These are all given, so you don't have to do anything with those, but I just wrote them down. And then as we do the reciprocal, secant, we'll flip that, that'll be 8 over 7. And then cotangent is going to be equal to 7 over 15. So once again, 7 over square root of 15. So once again, I'm going to leave 1 just to show you it's accepting it like that. Like you don't have to go ahead and do that extra step. And then 1 I'm going to change just to show you once more. So cosecant I'm going to put as 8 square root of 15 over 15. Secant I'm going to put as 8 over 7, and cotangent I'm going to leave it in its improper form, 7 over the square root of 15. Okay. And it accepts them all for right now, but actually this is not the correct form. Just be mindful. Okay, so on this one, number 3, we have some extra work to do. So they give us 1 trig value, and you have to find the other 5 remaining trig functions. So this one we have to do a little bit of work. So what you're going to do, you're going to draw a right triangle. Doesn't matter the orientation. Okay, you can put that angle anywhere you want. So it's phi. Phi is the angle that we're using. Okay, so I'm going to put phi here. And if I'm thinking about tangent, okay, tangent of phi, tangent is equal to adjacent over opposite. Or no, I'm sorry, it's backwards. Tangent is equal to opposite over adjacent. Okay, sorry. Tangent is equal to opposite over adjacent. Well, they told me that tangent is equal to 8. So if I make that a fraction, that would be 8 over 1. So according to where I put phi, opposite side right across would be 8, and the adjacent side touching it would be 1. So this isn't drawn to scale, but this is how you would label those sides. Now, since this is a right triangle, we can find the missing side by doing Pythagorean's theorem. So we have to do a squared plus b squared equals c squared. Okay, so A and B are the legs. It doesn't matter which one are the legs, but the one that does matter is the hypotenuse, the long side. So this side has to be C. It doesn't matter which one I put, 8 or 1 for A or B. So we're going to find the missing side, and once we do that, we can solve the other trig functions. So what we're going to be looking for are sine of phi, cosine of phi. We're given tangent, and then we're going to find cosecant, CSC of phi. We're going to find SEC, secant of phi, and then we're going to find cotangent of phi. Now cotangent we get for free because tangent was equal to 8, and if we just flip that, the reciprocal, that would be, think about 8 over 1, this would be 1 over 8. Okay, so that one I can get for free. Just got to find these other ones. So we're going to plug in 8 here, so we're going to say 8 squared plus 1 squared equals C squared. This is going to be 64 plus 1 equals C squared. So we have 65 equals C squared. And then to get C, we don't want C squared, we want C. We have to take the square root of both sides. So the square root of 65 equals C. We take the square root of both sides. So this side is the square root of 65. Now from here, we can find the missing sides. So now that I have all sides of the right triangle, if I want to find sine, sine is opposite over hypotenuse. So 8 over the square root of 65. And then to get this one, I just have to flip it. So I'm going to write the square root of 65 divided by 8. And then cosecant is adjacent over hypotenuse. So this would be 1 over the square root of 65. And this would be the square root of 65 divided by 1. When you divide by 1, you get itself. So again, the ones with square roots on the bottom, you want to rationalize. I'm not going to go through the process, but I will rationalize them both. Or actually, I'll just leave them both the same, just for the last time doing that. So we'll say 8 divided by the square root of 65. We're going to say 1 divided by square root of 65. Cotangent is going to be 1 divided by 8. Cosecant going to be the square root of 65 divided by 8. And then secant will be just the square root of 65.